Okay, note 7, the binomial distribution. So first we're going to talk about Bernoulli trials, and we talked about that a little bit in that pop quiz activity. So it says the requirements for a Bernoulli trial is that we have to have two possible outcomes. The probability of success has to be the same, and the trials are independent. For Bernoulli trials, we use what is called a binomial probability distribution. Okay. There are 4 things that must be true in order to consider using a binomial probability distribution. And the first thing is that we have to have 2 possible outcomes that we call success or failure. We have to have a fixed probability, and that is called the probability of success P. We have to have independent trials. And even if we can't prove that it's independent, as in the problem doesn't say these trials are independent, then we can use what is called the 10% condition rule. And what that says is that if you are sampling from a large enough population, you can proceed with sampling without replacement as though the trials are independent. Okay, let's see. So what this means, okay, so what the 10% condition means is that if you have at least 10% of the overall population in your sample size, then you can make the assumption that your trials are independent. For example, let's say your population is 2,000 students. That means you would need at least 10% in your sample size, and that would be at least 200 students. If you had 200 or more students, then you could assume independence based off the 10% condition. And then the one thing that's different than those Bernoulli trials is that the binomial probability distribution has fixed trials, what we call N. And what that means is they're going to say, okay, we're going to do this experiment 50 times. Once we hit 50, then we're going to calculate all our successes and failures. Okay, we're not going to go past 50 and we're not going to go under 50. We're going to hit exactly that set trial of N equals 50. Okay, so once those are all satisfied, then we're able to use the following formula, which is located on your formula chart. So this is the probability is equal to N choose X of P of X times 1 minus P to the power of N minus X, where N of X is equal to N choose X, which is N factorial over X factorial times N minus X factorial. The mean is going to be mu of X is equal to N times P, and the standard deviation is going to be equal to the square root of N times P times 1 minus P. Okay. So what each of these parts of the formula, what they represent is that the first part is saying that the probability of getting exactly X number of successes. Because remember, this is your random variable. Okay? This is your number of successes. Okay? N choose X are all possible outcomes of X. P of X is the probability of success for all successes. And then 1 minus P to the N minus X is the probability of failures for all failures. Okay. So in these examples, they're going to give us a situation, and we're going to have to set up each of the following so we can solve the binomial probability distribution model. So it says you toss a coin 10 times and count the number of tails you get. So X is the number of tails. We have two possible outcomes, tails and heads. We have a fixed probability of 50% or 0.5. We know they're independent trials because every coin flipped doesn't impact the other. So yes, they're independent. And there's fixed trials because we're going to toss the coin 10 times. So in order to find this, we're going to find the probability that X is equal to 4. And what's important, especially for FRQ, is that you write down that formula. So we're not going to end up using this formula. We're just plugging in all the values where they belong. And then we're going to go to Desmos and solve. So for now, I'm just going to give you the answer, and then later I'm going to show you how to do this on Desmos. So the next one says, a company reports that 75% of emails it receives is spam. You have 25 emails in your box. So X is the number of spam emails. We have two possible outcomes, and that is if the email is spam or not. We have a fixed probability. It gives it to us as P equals 0.75. Independent trials, we can assume you get many emails in your box. So yes, this is independent because we're assuming you get more than 25 emails in your box. And fixed trials is N equals 25. So what we're trying to find is P of X is equal to 20. So we would say P of X is equal to 20 is equal to 25 choose 20, 0.75 20, 1 minus 0.75 to the 25 minus 20. And this gives us that the probability that X is equal to 20 is equal to 0.165. So in other words, this is saying the probability that you will get 20 spam emails in your inbox of 25 is about 0.165 or 16.5%. Okay, part 3 says type A blood is found in 43% of the population. You have a group of 40 students. So X is type A blood. Two possible outcomes is either if it's type A or not. Fixed probability, they give it to us as P equals 0.43. Independent trials, well, we can say that they're independent trials because there are many students in our population, so yes. And then fixed trials is N is equal to 40. So it says find and interpret P of X equals 15. So P of X equals 15 is equal to 40 choose 15, 0.43 to the power of 15, times 1 minus 0.43 to the power of 40 minus 15. So this gives me that the probability that X equals 15 is equal to 0.101, or in other words, the probability you get 15 students out of 40 who have type A blood is about 0.101 probability, or about 10%. Okay, so now we're going to look at what this is going to look like on Desmos. So here it breaks down how you would see it on a calculator. So we don't need any of this information, right? Because we are doing Desmos. And what's nice about Desmos is unlike the calculator, you need to know what it means by PDF and CDF. Okay, calculator, you need to know that. Desmos, it does it for you. But just so you know what this means, PDF is a probability distribution function and is used with the distribution when you're trying to calculate P of X equals X. So P of X equals X can be computed using binomial PDF and PX. Again, this is more on like the TI Inspire. Okay. CDF, or commutative distribution function, is used with the distribution when you're trying to calculate the probability of an interval of values. In other words, we have an inequality sign. So that's like saying probability of X less than or equal to X. Okay. So let's look to see how that would look like on Desmos. So before I bring up Desmos, let's go ahead and label our N, P, and X. So N, remember, is our number of trials, so that would be 40 students. P is our probability, so that would be 0.43. And X, it says exactly 20 people, so it's going to equal 20. So we're trying to find the probability that X equals 20. So in order to find that on Desmos, these are the steps that we're going to follow. First, we are going to find the plus sign, and we are going to click on inference. Once we are on inference, we're going to select probability distribution and then select binomial distribution. From there, they're going to have us type in N and P, but they're going to call them by their name. So they're going to say, what is the number of trials and what is the probability of success? Then, once we click OK for it to create that distribution for us, we're going to click on the drop down that says cumulative probability. Cumulative probability. And then from there, depending on what type of problem we're looking for, if it's going to be X equals something, it's going to be the probability of something less than or equal to X, less than or equal to something. So in this case, we're going to plug in 20 in both spots because this is representing probability of X equals X. Okay, and then for N, we're going to plug in 40, and for P, 0.43. Okay, so plugging that in, I'm going to go ahead and open up Desmos. Okay. So I'm going to go ahead and do the same steps. So I'm going to hit plus, inference, probability distribution, go down to binomial distribution. The number of trials is 40, and the probability of success is 0.43. Create distribution. Then I'm going to go down to cumulative probability, and then since I need to find X equals 20, I'm going to do 20 and 20. Which means I just found that my answer to this is 0.084. Okay. So let's go ahead and look at the next one. Notice that N is still 40 and P is still 0.43. Now it's asking what is the probability that 20 people or less in our group have type A blood. So 20 people or less is going to be X less than or equal to 20. So we need to find the probability that X is less than or equal to 20. And I'm going to go back over here and I'm going to look at each of these regions. So this is inner, outer, left, and right. Notice that the inequality that I want is on the left region where X is less than or equal to 20. So since 20 is already inputted here, I have 0.854 as my answer. Cross out all this. We don't care about that. And let's continue on more examples. Notice on these examples, we're still using the same N and P values, so the only thing that's going to change is our probability of X. So this says the probability that 14 or more students. So that's the probability that X is greater than or equal to 14. So I'm going to go hit the right one, and I'm going to change this to 14. So this is equal to 0.882. This one says the probability that less than 10 students. This is where we're going to have to really think about this because look at all our regions here. All of them have less than or greater than or equal to. Sorry, less than or equal to or greater than or equal to. None of them have just less than or just greater than. So technically, if we were to write less than 10 students, this would be X less than 10. But we can't write that based off what we're already given. So I would say this is the probability that X is less than or equal to 9. Because if you're less than 10, you're not including 10, which means you're going straight to 9 anyway. So X less than 10 and X less than or equal to 9 is going to be the same thing. So I'm going to find the correct one, so that's the left region, and I'm going to change this to 9, and I get 0.006. And then lastly, what is the probability that you have more than 30 students? That means you're not including 30, you want more than 30. So this is going to be the probability that X is greater than or equal to 31. change my region to right, so that's where it's greater than or equal to, and change that number to 31, which gives me the probability of 9.5 times 10 to the negative 6th power, which is a very, very, very small decimal. That's the same as saying 0.00000095. Very small probability.